Welcome yet again to another session today on mathematics. Today we are dealing with the topic place value of whole numbers and digits in decimal. In a nutshell, or in a proper way to put it, let us say we're talking about the place value of whole numbers and decimal numbers. Simple as that. Place numbers of whole numbers and decimal numbers. Question is, what are we going to be achieving today? Today we are going to be achieving the placements. Our objective is to conclude the placement of values in a given set of numbers and what each value entails, what each value is all about, the description of each value. In a series of numbers, you're going to see how or the structure for those numbers as we go on. We also use charts. We use charts to understand where each numbers are placed. Hence the word place value. We'll also be talking about the difference between whole numbers and decimal numbers. What differentiates these two particular sets of numbers? What's the main deal with them? So we're going to be finding that when the time comes. Are you ready? Let's go. Now we're going to talk about place value. What is place value? Place value is the value of each digit in a number. Every number has its own place in the sets of numbers that are given. Every digit has its own place in the sets of numbers that are given. For example, 5. If you look at 5 in the representation on your screen, 5 in 350 represents 5 tenths. 5 in 350 represents 5 tenths, or you can call it 50. Because it is representing the part where you are meeting 5 times 10, hence the word tens. So we are talking about 5 tens, 5 times 10, which means it is on the position of 50 as our place value. However, the 5 in 5006 represents 5,000 or 5,000. What that means is you do not take cognizance of that 6. In that place value, the value or the digit 6 represents a place value for 6 units. As we go further, you will see more about what we mean. It represents a place value for 6 units. That means that 5 is for 5,000. Note, it is important that we understand that whilst a digit can be the same, its value depends on where it is in the number. While a given value is given, while a value or a digit is given rather, the value of that digit is dependent on the particular place, the particular number, that the particular position that number is found. So its position is what gives it its classification in terms of the place value. Hence, in mathematics, every digit in a number has a place value. Every digit. There is none that is different. Even down to the highest level. In this our case, we'll see up to millions and even billions. But the thing is, it goes as far as you can go. As long as that number is a feasible number, is a countable number, that number has a place in the value system. Now, in the screen, you can see the place value chart. You can see we have the millions. I will represent it also on the board for you to see for clarification. You have the millions, you have the 100,000s, you have the 10,000s, you have the thousands, you have the hundreds, the tens, the ones, or the units. We call it the ones or units. It depends on what classification or what semantics you choose to use at that moment. Then we have the defining moment. We shall see more about this particular moment when we get to the difference between whole numbers and decimal numbers. Then we have the tenths, the 10th, the 100th, the 1000th, 100,000th, and millionth. But of course, like I said, it goes way higher. It goes to the point of that we even have the tens of millions or 10 millions. We have the hundreds of millions or the 100 millions. We have the billions. And on the other hand, we also have the tens of millions. We have the hundreds of millions. We also have the billions. It goes as far as the trillions, the quadrillions, the quintillions, the sextillions, the septillions, octillions, nonillions, and the decillions. So you must understand that every number, as long as it's a feasible number, as long as it's countable, it has a place value. Let's see some case scenario. Now you have this number, a set of number that is given 4000600. May I use this moment to, first of all, encourage that the first thing you do is to differentiate each of the numbers, like you can see at the bottom screen or the bottom of that representation. Differentiate each of those digits with a comma so you can know where to classify each of them. Place value, as much as it's dependent on the position, is also dependent on the classification. What do I mean by classification? Every 3 digits gives you a particular name. For example, the first 3 digits in every number set is 100. The next 3 is 1,000. The next 3 is million. The next 3 is billion, and so on and so forth. Meaning, you want to differentiate it, or you want to separate the number so you understand which classification it falls under. In this case, I'm going to count from right to left. From right to left. Let's see this now. Now, I count from here 1, 2, 3. It tells me that this group over here are hundreds. I fall under the hundreds bracket. I count again 1, 2, 3. It tells me this group over here are falling under the 1,000 bracket. Meanwhile, I have one man that is standing on the loan under the million bracket. Now, going digit or one by one to describe, as you can see on your screen, you have the first 0 to be under a unit. So that's under a unit because it's standing on its own. It's a 1. So under the ones. But because of the presence of two digits, it makes it a tens. Means a standing with another person. It's a double digit number. That's how we put it. It's a double digit number. Hence, it's a tens. Then the presence of the third one, which brings about the first demarcation, the first comma that differentiates it as 100, is 100 because it has triple digit number. The presence of the triple digit number makes it 100. Now, going further, you will see the next one, which is the fourth one there, and the beginning of the second segment. It begins in second segment. It's called the thousands. The 1,000. They will have the 10,000. Going forward, you have the 100,000 because you're taking cognizance of the same movement, the same pattern that was here when you had the 10, the same pattern that was here when you have the 100, is what is moving here. Now, it's moving in the sense that this guy is actually number, is actually 1. So it's like a 1,000. Yes, this guy was 1. This guy was 1, a single or units. So this one here is 1,000 or 1,000. This one takes the place of 10,000. So we have the 1,000, the 1,000 here, or 1,000, if you want to put it. You have the 10,000 here. Means it's a double digit of the tens mixed with the 1,000, the triple digits of the 1,000, or of the 100 rather. Double digit of the tens mixed with the triple digits of the 100, giving you 10,000. Then also, you have the ones that we call 100,000, triple. It's a triple digit of the 100, missing the triple digit of the 100, the other 100, giving you 100,000. Sorry, let me just write it up there. Then this one is falling under the purview of, after you pass the first 2 segmented or the first 2 classifications, which is the 100 and the 1,000, you get now to the next classification. The beginning starts with million. So that's how we know where each number falls under. The first digits, units or ones. Second digits, 10. Third digit, 100. Fourth digit, 1,000. Fifth digit, 10,000. Sixth digit, 100,000 rather. And the seventh one is million, or you can classify it as 1 million. But it doesn't end there. What if they ask us to find the place value of each of the following digits, as you can see on your screen? In this case, what will the value of 3 in that number, or rather in that set of number, what will the value of 3 be? If you notice, there are two classifications under 3. Now you have the 3 that falls at the tail end of it, and we have the 3 that falls at the beginning, somewhere here. If I put back the digits completely, it's something like this. What do I do first? I tend to demarcate or differentiate or put them in their classifications. We have 1, 2, 3. You put a comma here. 1, 2, 3. You put another comma. It tells me the presence of 6 digits after another number, or the presence of 6 digits tells me there is million. The last number there is million. So if I want to give the classification of 3 in this whole representation right now, the classification will be, since I know that this one will be units, that means this first 3 is tens. It's under the 10. Or 30. As we agreed earlier on. It will now become 3 times 10 because under 2 digits, 1 and 0. I'll give you a description of how the flow of the digits works. Then this one will be under I know this will be under the 100, the 1,000, 10,000, 100,000, and finally we have the million, or 1 million. How do I know? The question might come, how do I know where to classify each digit in a set of number? How do I know how to classify them? Good question, and I will show you how. Now let me quickly just erase this part. And then show you a classification on the lowdown, how it flows. So we have the 1 as the units. We have it goes in the placement or in the form of the binary. It goes with the form of the binary, which means you are using 1 and zeros. So every digit here will start with a 1 and it ends with a 0. As we are going to see. We are going to see that 10 now, 1 and 0 will be our 10. As we know in our digit counting numbers. Counting numbers, when you get to 10, is 1 and 0. Next will be 1, 0, 0. This gives us 100. Then we have 0, 0, 1,000. 0, 0, 0, 0. Again, now I'm going to do something extra here because I have added figures that will need me to classify and change, or to show the separation in the numbers or in the various classifications. I'm going to put my commas now. So I count 1, 2, 3 in the 1,000, and I put a comma here because this is my 1,000. I count 1, 2, 3 in the next number, and I see that it's 10. This is 10,000. 10,000. Then the next one is 1, 0, 0, 0, 0, 0. Again, I count 1, 2, 3. I find that 1, 2, 3 will end at the digit 1. Hence, it tells me that this will be 100. 3 digits here. 100,000. The next will be 1, 0, 0, 0, 0, 0, and 0. 1, 2, 3 gives me a command. 1, 2, 3 again can go, give me another 2, and I have 1 remaining. Tells me that this is million or 1 million. Let's see if we can get up to 9 digits of zeros. 1, 2, 3, 1, 2, 3. Presence of 10 tells me this is 10 million. One, two, three. 1, 2, 3. Presence of 100 tells me this is 100 million. Finally, 1, 2, 3, 4, 5, 6, 7, 8. Let's get it 9 zeros now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, separate. 1, 2, 3, separate. 1, 2, 3, separate. Presence of 9 zeros, and in the classification that I have 1 as a unit, tells me that this is billion. And I will end there. Now we have the other part of the decimal number. The other part of the decimal number that makes up the place value. Now the decimal system talks about the decimal point. Now what is the decimal point all about? Is the differentiation that makes the whole, or differentiates the whole numbers from the decimal number. That's what the decimal point is all about. It will differentiate the whole numbers from the decimal numbers. And in this classification, it means every digit that comes after the whole number is a fractionable number. Is a fraction number. Is a small, minute number. It's not as big as the whole number. It's like the fraction number. Thus, decimal number can also be written in a fraction number format. What do I mean? Let's continue with our structure over here. If you followed up to the billion, let's see if we can get up to, let's see if I get up to millions here. And perhaps we might be able to finish it up later. Now, your decimal point will now come here. So this is your decimal point, just a dot. Then we have classification that goes this way, 0.1 or 1/10. The presence of 10 tells you is under the tens. The presence of 10 here tells you is under the 10. Is an inverse of the 10. The presence of 1/10 tells you is an inverse of the 10. And going forward, you might be going through or going for your external examinations, and you will come across a classification that shows. Sometimes they will give you something like this way. Whenever you see the presence of those three representation here are the same thing. Decimal number, fraction number, inverse number. Decimal number, fraction number, inverse. 3, same thing. All tells you this is tenth. Now the difference between, like I said, fraction means it is lesser than the bigger, than the whole number, than the bigger number. Hence, this one that are moving with capital letters, the decimal numbers move with smaller numbers, and they are denoted by TH, telling you it is a smaller number. Hence, you have tenth. Now, it's not necessarily the first digit I use here that makes it a smaller number. What makes it a smaller number is the presence of the TH. Tenth. So it flows in that way. The next one will be 0.01 or 1/100. I'll leave this one for you to fill up. Then this will be 100. Next is 0.001 or 1/1000. I might need to remove clean up this path so that you will be able to see the full view of what I'm describing. This will be under thousandth, because the presence of 1,000, the presence of 1,000 here, presence of 100, hundredth, presence of 1,000, thousandth. Then 0.0001 or 1 over 1000. 1, 2, 3, comma here, tells me that this is tens of thousand. And if it's tens of thousand in the normal way, it will be 10,000th. The presence of 4 zeros here tells me it will be 1 over 100,000, which means the presence of hundreds of thousands tells me this will be 100,000. And finally, 0.000 001. Okay, it tells me this is 1 over 1000,000. All right, comma. Presence of the 1 and the 6 digits of zeros after the 1 tells me it is under the million fold, and thus this will be millionth. All right, let me stop here for now so we can see the structure. So this part, these are whole numbers. These parts, these are decimal numbers. Whole numbers, decimal numbers. Now let's see some facts about the decimal place values. Decimal numbers are mixed numbers with denominators of powers of 10. In the decimal number, the digits to the left of the decimal point represents a whole number. What it means is you're having a series of numbers that says 23.04. These digits all to the left, after the decimal point, digits to the left, whole numbers. Digits to the right, decimal number. The digits to the right of the decimal represent the parts. So one is a whole, is complete. The other one is in parts, is in pieces. The place value of digits becomes 10 times smaller. It becomes 10 times smaller. In terms of the decimal place value, it becomes 10 times smaller. So that's some facts about decimal place value. The first digit on the right of the decimal point means tenth. That is 1 over 10. Its first digit means tenth. That is 1 over 10. And so on. It's not unit. There's not a unit. It takes the position of 1 over 10 because of the classification where it falls. It's taking a position where it's taking 2 areas. The points and the first representation, the first number. The first number after the decimal point. These are the 2 classifications. Now let's see an example. You're having in this case, in the set of numbers, 27.356. Now you notice that digits to the left, as we earlier on established, digits to the left are whole numbers. Hence, 27 is whole number. A whole number is any number that occurs or comes before the decimal point. Know that very well. One more time, we'll take it. Whole numbers are numbers that comes or occurs before the decimal point. Meanwhile, decimal number, this is the difference. Decimal number are numbers that occurs after the decimal point. So 27 is the whole number, which means 2 is a tens place, and its place value is 20. It's under 10, its place value is 20. 7 is the ones, it's under the ones, the units, or the unit place, and its place value is just 7 as 1 unit. There are 3 digits to the right of the decimal point. Those 3 digits are 3, which is the 10th place. It takes the position or the place value of 0.3, like in this case, 0.3 or 3 over 10. We have the next one as 5, which comes after the 3, and the 5 is the 100th place, and its place value is 0.05 or 5 over 100. We have finally the one that comes at 6 immediately after the 5 is the 1000th place, and its place value is 0.006 or 6 over 1000. You must understand that this whole placing of the numbers is what will help you to calculate properly. So if for your arithmetic to be properly done, your numeracy must be accurately done. For your arithmetic to be taken carefully, your numeracy must be handled carefully too. So you must get this note. Get this note right now. The place value of a digit is different from its face value. Now, question may arise, what is the face value? The face value of a digit is the digit itself. For example, going back to what we have on the board here, this illustration here, 23.04. The face value of this number here is actually 2. It's 2. But the place value is 20. Why? Because 2 is 2. Under the counting numbers, we have 1, 2. You didn't call it 20, you call it 2. Thus, the face value is 2 here, but because of its position, its placement, it is now under the tens position. Thus, it's now 2 times 10, hence it gives you 20 as the place value. Face value is different. Whatever place it may be, it is unchangeable or definite. But place value changes according to the digits placement. Like I said, according to the digits place, it changes. But face value never changes. It's the same thing. Now, let's evaluate what we have done so far. Now, if I ask, find the place value of 7 in the following numbers, what will the answer be? Now, the key thing to understand there, let me just quickly remove everything on this board. So while we are concluding, this is our conclusion. The key thing to understand there is that they all fall under different positions. The first position and the first description there was 7531. I said earlier on, find a way to split it up, break it up, or separate it so you know. You count from right to left. 1, 2, 3, comma. It tells you presence of 3 gives you 7 times 1, 1, 0, 2, 0, 3 zeros. These whole digits here represent the zeros. And if you do this, the placement of 7 in this is equal to 7,000. Naturally, you know that it's 7,000 from the placement of the 7 because you have differentiated, you have separated it. You've done the counting and you separated it with the comma. So you know it's 1,000. But the question is, what kind of 1,000 is this? It is 7,000. So in the second evaluation given there, we asked to do 5731. Now again, like I said, count from right to left to differentiate and separate so you can know where each of the digits falls under. I count 1, 2, 3, and I got 7. Now in this case, it tells me because the 7 comes after the 1,000 and also it has 2 digits after it. Tells me it's falling under 7 times 1, 2 digits, 0, 0, representing them with 0. Tells me it falls under, and this is now 700. Tells me it falls under 700. The next one, 5371. Now the presence of 1, 2, 3 again, 1,000. I have seen that the 7 doesn't fall under the 1,000 here. It doesn't fall under the 100 here. Where is it falling under? We put the 7 back, 1 digit after the 7. Tells me it's times 10, 1 and 0. Thus, because it's under the tens, it will be 70. Then finally, 5317. The presence of the, 5137 rather. Pardon me. 5137. 1, 2, 3, I put my indication. I noticed that the 7 doesn't fall under the 1,000. It doesn't fall under the 100. It doesn't fall under the tens. It's actually standing alone. Hence, I know that the 7 is times 1 as a unit. The 7 now is 7. 7 units. With all this, I'm sure you should have gotten the lowdown on how to place or how to move your place value. Just to add to this, now what if we have a continuation? Now what if we have something like this as a fifth one? Just to add to this, you have 5130.7. Good question. This is where your decimal place value comes in. 1, 2, 3, I put my comment. It's not under the 1,000. It's not under the 100. It's not under the tens. It's not under the units. In fact, it's after the decimal points. It's standing alone. That tells me that since it's 1 digit after the decimal point, just 1 after the decimal point, it tells me that this is now 7 times 1 over 10. Yep. Or 0.1. If you do the calculation for this, you will find out that it will become 7. In this case, it will become 7 over 10 or 0.7. Thus, 7 is in this representation, this set of number here is falling under the 7/10 of a number. Having done that, we can now try the following questions at home. Ensure you just practice it. Practice it at your given free period. See how good you are to find the value of the following numbers. Now, coming back to this example one more time, what if you're given a question, as in the case with that first instance over there, you're asked to find the sum. Of course, you know that sum is addition. Difference is a subtraction. Now, you're asked to find the sum of the place value of 7 in the case study 1 and case study 3. So I'm asked to find the sum, which is add case 1 and case 3. What do I do? It's simple. I know that I have 7,000 in my case number 1. And in my case number 3, I have 70. Just to add them, you have 0 plus 7, 7. 0 will come down, 7 will come down. Hence, my answer now becomes 7,070. 7,070. Hence, if you want to pronounce it in words, 7,000 is over here, 70 is here. So your answer is 7,070. What if you're asked to find the difference? In this case, difference means subtract case study 2 from case study 4. Subtract case 2 from case 4. Simple. I'll do it over here. You come here, you check where case study falls. Case study 2 falls under 700, or it is 700, and case study 4 is 7. So minus, I put my minus and I put my 7 over here. I know that 0 minus 7 is not possible. I borrow from the only person who has something significant, a significant number, 7. And when I remove 1 from here, 7 becomes 6. I move to this one becomes 10. But 10, this one is still not having anything. This one remove, give to this one his 1, and he becomes 9. And this one becomes 10. 10 minus 7 will give me 3. I bring down my 9, and I bring down my 6. Thus, the difference between case 2 rather, and case 4 is 693. Now, with that in mind, I want you to do the questions on your screen at home. Now, quickly, let's get some questions from our exam guide, where past questions have been taken down. Let's see if we can answer 1 or 2 past questions given to us. Now, the question I'm taking is from the year 2021. And there are a couple of questions there that interest me a lot. One of them is this one. So, what is the place value of 7 in the number 526.97? What is the place value of 7 in the number 523.97? It's a good thing we've already been dealing with things that have to do with 7. So you can find out that life will be a lot easier because you're already working with 7. Now let's see the place value. They gave us 526.997 rather. Please pardon me. You notice that the place value, you count 1, 2, 3. The place value of 5 here is 100. Place value of 2 here is 10. This is a unit. You have a decimal point. Then we have 9. It's under the digit after the decimal point. And we know that one is 10th. So 9 is under 10th. It then means after 10th, the next thing we have is usually hundreds. So 10th, this will become 100. Thus, the place value of 7 in the given figure, in the given numbers, is 100th. So it then means your answer there in that classification will be 700th. 700th. So that's for that one. Let's see another question that has to do with our place value. Now we have question number 3. They said, look, what is the place value of 7 in the number? And this time they gave us, there's no decimal point. We've just worked with hundredth. Let's see the one that has whole numbers instead of decimal number. And they gave us series of values here, series of numbers. 2, 3, 7, 6, 4. So the series of digits gives us 2, 3, 7, 6, 4, 0, 0, 7. Or rather, 0, 0, rather. That's a question mark. So I told you what to do first. Count from right to left to split or to separate, so you can know where each number falls under the position of each number. So you can also determine their value, their place value. 1, 2, 3. At the 4, I remove a comma here. 1, 2, 3, another comma here. It tells me that 2 standing alone after 6 digits will become million or 1 million. 3 is hundreds of thousand, 100,000. 7 now is under tens of thousand, 10,000. 6 is under thousand. 4 under 100. And then we have 0 as 10, 0 as units. Looking at this, my classification will look where 7 is. And 7 is telling me tens of thousands. It means 7 times 10,000. Hence, my answer is 70,000. That is the place value of 7 in the given digits or the given number. Please ensure you always count very well, because your counting number skills will come to bear when it comes to place values in terms of whole numbers and decimal numbers. Take care and have a wonderful day.